My name is Ashish Kumar. I'm an assistant professor, Department of Computer Science and Engineering. And today my subject is operating system. Subject code is BCS 401. And this is my lecture 5, RAID. In that lecture, I have to discuss about the RAID and file system. In that topic, we have to basically discuss RAID and type of RAID file and file attributes, file allocation methods. Okay, already in a previous lecture I have to discuss about the RAID. In this slide already have to discuss RAID, what is the RAID, and how to store the data in a RAID. So RAID 0 and RAID 1. Last time I have to discuss about the RAID 1. In RAID 1 basically a different data set. If you store any one disk, then generally you have to create a copy of disk. So A, B, C are stored as it is, no changes of data, as it is stored in different disk. Because if one disk is collapsed and corrupt, another disk is available for execution any problem, because my data is available. Okay. Again, we have to see that RAID 2. Redundancy scheme RAID 2 is Hamming code. The strips are very small in this label, often as small as single byte or word. A Hamming code is calculated across the corresponding bits position the disk. The bit of codes are stored in the preceding bit position. Multiple disk rarely implemented. To basically rarely implement, because you have to see that in a RAID 2 data divided different form, and different parents you have to store the data. So RAID 2 basically not implement maximum times. Just to see that the here move on the RAID 3. RAID 3 is the most important. RAID is organized in a similar fashion RAID 2, but is the required only a single disk. RAID 3 imply parallel access data discrimination is a small strips. Instead of error correcting code a simple priority. Basically, it is work on the priority based. What is the meaning of the priority? Suppose a data is 6. Okay. In a A1, we have to stored suppose 1. A2, 2, 80, 3, and a parent. That means here mention its individuals, strips, priority. Basically, it is called a priority disk. In a priority disk, basically store the whole data. Suppose 6 overall data is stored in the priority. So sometimes A1 plus A2 plus A3 is equal to 6 or AP. Okay, data is stored AP form. Okay, if data of A1, suppose a data of A1 corrupt, you know that how do you know in a A1 disk which type of data available and data values? So through the priority, suppose our data of A1 is X, A2 is value is 2, A3 value is 3, and value is 6. So X value is 1. You have to find the, through the priority we have to find the data. But in case of number of 2 disk is corrupt, so possibilities anytime there. So maximum you have to secure the data through the RAIDs. Next is RAID 4. RAID 4 basically similar to RAID 3, no changes, but RAID 4 is divided block wise. Suppose block Y1, A2, A3. In this, you have to see these pictures in this form, and as it is similarly same, no changes. So here you have to just give the theory. It is a similar RAID 2, 3, but RAID 4 is divided block wise. block or greater than beat and only one disk is used. The main disadvantage is that the parity block on driven can be bottleneck during the operation. Next is RAID 5. In a RAID 5, priority disk, different priority are different data of priority are stored different disk. So if in previous slides, basically one problem, if priority disk is crashed, so no priority value is available. But in that figure, different disk or different priority are available. So at a one time, whole priority is not lost. So data security is increases and data availability also increases and throughput also increases. Starvation problem decreases. So this is the basic. Through the RAID 5, basically you have to find this, solve this problem easy way. So different position of you have to priority are stored and you have to finding the data. Next, not RAID 6. RAID 6 basically two priority are uses. In a RAID 6 basically two priority. If one priority are lost, another priority is available. So maximize the copy of data and maximize the security of data, maximize the availability of data through the RAID 6. RAID 10. RAID 10 is basically combination of RAID 1 and RAID 0. So given some theory, RAID 10 is also known as RAID 1 plus 0. Is a RAID configuration that combines disk mirroring and disk stripping to protect data. It requires minimum 4 disks and strip data across the mirrored pair. This two number format of RAID 10 in 1 plus 0 is known as nested RAID. Other nested RAID level are RAID 01 plus 0 plus 1, 03 03, 50 5 plus 0. Now that means mirror creating data availability. At your level, you just need to know RAID 1 plus 0 mirror then strip, RAID 0 plus 1 strip then mirror. So in RAID 0, you have to study about stripping the data, and RAID 1 you have to study copy of the data. So in this basically we have to see that RAID 1 basically create a copy and RAID 0 basically stripping the value of data as it is same different. Next topic, what is a file? All of you know that file क्या है? A file can define as a data structures which stores the sequence of records. File are stored in the file system which may exist on a disk or in the main memory. File can be simple plain text or complex special formatted. Where data is write down, where data is stored. The collection of file is known as the directory. Any directory, number of files are stored in different manners. The collection of files known as directory, that is called the folder. The collection of directories at the different level is known as the files. The collection of directories at the different levels is known as the file system. Okay, different directory stored in the one places, that is called the file systems. Here basically attributes of file, all of you know that there's a simple, all of you, most time of you have to use in an exam. This is a basically 5th unit of the operating system. So in an exam basically just ask the theoretical questions regarding from the files, and here mention the attributes of the file. 2 marks questions is basically asking what attributes of files is name, identifier, types, locations, size, protection, time and date. Name, every file carries, all of you know that every file carries a name by which the file recognize the system files. One directory cannot have 2 files with the same name. One directory, all of you see that if same file name you store in a directory, so directory basically give the ask the question, a file is, this name file is already in here in that place, so can you replace this file? In this type of questions, maximum time asking a folders. So you have to select replace and not replace, so you not saving the same names. Along with the name, each file has its own extension which identifies the type of the file. For example, a text file has the extension .txt, a video file can have the extension .mp4. Types. In a file system, the files are classified in different types such as video files, audio files, text files, executables files, etc. In the file system, there are several locations on which the file can be stored. Each file carries its location as its attributes. The size of files. You have to see this slide, and just to have not read on one by one. So move on the file operation. How to file creates. First create the files. The creation of files. The most of important operation on the files. Basically, different types of files are created by different method. For example, text editor are used to create a text file. Word processor are used to create a word file, and image editor are used to create the image files. And write, file write, read, repositioning, deletes, truncate. Truncate basically simply deleting the files except deleting attributes. The file is not completely deleted, although the information stored inside the file, it can be replaced in a truncate manner. So file allocation methods. Next is file allocation. How to allocate the file? So here mention some points. File is allocated on contiguous manner, linked allocation, and indexed allocation. The allocation methods. The main idea behind this method is to be provide efficient disk space utilization, fast access to file block. All the three methods have their own advantage and disadvantage. First, contiguous. To move on these pictures. In that pictures, suppose in this picture, basically a file name is count. A file name is count, and count starting value is given 0, a length is given 2. That means a file size is 2 bits are given. So in this storage of files, basically in this format, this is the sectors. So file size is 2. So these two positions are in sequence form, you have to cover. Next, TR. TR is 14, starting point is 14 here, 14, and file size is 3. So 3 locations we have to continue cover. Okay. Another mail. Mail starting value is 19 here given, and size is 6. Then you have to continue 6 position or cover, and another is 28 and size is 4. So you 4 position you have to cover, and another file is given 6 and 6 is file is 2. So 2. So basically we have to design on a sequence manner of this file located in a disk, but some advantage and disadvantage are given, because both the sequence and direct access are supported by this file. Okay, direct access, the address of the file, matlab easy to access file and easy to store of the file, no problem. This is extremely fast since the number of 6 are minimal because the file is continuous manners. Disadvantage, this method suffer the both internal external fragmentation. How internal external? Because in that place, suppose 8 size of file are, suppose one file is D, starting position is given 2 and size is given 8, Can I insert in this position of that files? No. But space are available in whole disk, because 2, 4, 6, 7, 8 number of position are backend, but you have to not use this. That is called the external fragmentation. And file size not contained internally, that means basically it is a block. The block, whole block, suppose different block are given, but if file size as minimum, then we have to cover the whole block, so it is also called internal fragmentations. This increasing the file size difficult because it is the depend on the ability of continuous memory particulations. If size of it is increases from 9, so 9 position are available continue or not? No. So not increase the file size. Again, linked list allocation. All of you know that what is the linked list? Linked list basically in this manner: value and address of next position. In this manner worked. Basically, it is store the address of another data. Okay. So in this scheme, each file is linked this block, which need to not to be continuous. The disk block can be scattered anywhere on the disk. The directly entry contains a pointer to the starting and the ending file block. Each block contain a pointer to the next block occupied by the file in this manner. Yes, see. Suppose a zip file name, and that position is 9. Okay, 9th position, and ending is 25. 9th position ending with 25, and store the data different locations. Okay. So no problem. So the all of you know that one value basically store the one block basically store the value and address of another data. So you have to easy to find the data, no problem. And internal fragmentation is all external fragmentation or resolved. Okay. So this is very flexible in term of file size. File size can be increased easily since the system does not have the look for the continuous chunk of memory. This method does not suffer from external fragmentation. This method does not suffer from external fragmentation. This make it relatively better in terms of memory utilization. And disadvantage, what is disadvantage? Because the file block are distributed randomly on the disk, large number of seek time is required. Seek are needed to access every block individually. This makes linked allocation slower. It does not support random or direct access. We cannot directly access the block of a file. A block K of a file can be accessed by the traversing a K block sequentially from the starting block of the file via block pointer. Pointer require the link location, incur some extra overhead. Next is indexed allocation. In this scheme, a special block known as the index block. One block are introduced in an index allocation. Contain the pointer to all the block occupied by a file. Each file has its own index block. The ith entry in the index block contain the disk address of the ith files block. The directory entry contains the address of the index block as shown in the figure. So move on the figure. Just you have to understand this figure. Okay. Here mention 19 is the index block and data is plotted. Every places in a disk, different locations. You have to read a book in a book for first page, your index page. Index page, you have to see that that topics basically related on this page to that position, that page. So we have to just go on that page. We have to read the different story, mathematical series, everything, and complete your topics. So index is a work on book index values and another index values. Through the index, basically the summary of the any data, where data is stored and where data is placed. So here mentioned 19 number is block is your index. So I've discussed here. Advantage: this supported direct access to the block occupied by the file and therefore provides fast access to the file blocks. It overcomes the problem of external fragmentation because every value are uses easy way. The pointer overhead for the index allocation is greater than linked allocations. For very small files, says file that expand only 2 to 3 blocks, the index allocation would keep one entire block for the pointer, which is inefficient term of memory utilization. However, in the link, what for very small files, say files that expand only 2 to 3 blocks, because different index blocks are created if your size or file size increases. File size increases allocation will keep one entire blocks, index blocks, the pointer, which is insufficient in the term of memory utilization. However, a linked allocation, we lose the space of only one pointer per block. What is in one? In this figure, basically you see that if index size are increases, so we have to move on the another block to create for indexing. So basically it is a cover the different block from indexing. So this is a major issue. So here in this point, for very small file, says file that expand only 2 to 3 blocks, the index block. So this line basically create a problem, main disadvantage, and external fragmentation, all of you know, because the store the data any places in a disk. Exam point of view, basically in a exam, most of time I've seen that what is the file allocation method. So you have to easy to write, keep file allocated in different way, 3 different ways: contiguous allocation, linked allocation, and index allocation. And you have to write some diagram. Through the diagram, basically you have to understand and understand the other person how to work in a file. So use this diagram, different diagrams, and easy to explain, and got a maximum marks in that types of questions. So maximum times in a 5th unit, that question are available in a UT university papers. So we are prepared. So okay, thank you.